Okay, today we're talking about the altitude of a triangle. The altitude of a triangle is a perpendicular segment from a vertex of the triangle to the line containing the opposite side. So from the vertex to the opposite side, as we see here. Okay? As we see, from the vertex A to the opposite side, we have a line or a segment that is at a 90-degree angle. Notice it doesn't go through anything. The key thing is that it forms a 90-degree angle. And so here in the triangles below, here I have an acute triangle. So if I were to draw an altitude, I see I have that. Here I have a right triangle, so that my two legs here form the altitude. And here I have an obtuse triangle, so my altitude is actually on the outside, and I have to extend the lines. So if you notice, with an acute triangle, it's inside the triangle, the altitudes. With a right triangle, it's one side is on, or sorry, two sides of the triangle are on the actual. And then for an obtuse, we have two sides are outside, and then this third guy, we could draw like that. Okay? So that is where all of our altitudes are. So acute is inside, right is on, and obtuse is outside, is where predominantly most of the altitudes are. We also use altitudes to calculate area of a triangle. You may remember area from your middle school days of a triangle. So to find the missing measurement, they gave us the area. So area is equal to base times height divided by 2. So area is equal to base times height divided by 2, where the base and the height form a right angle. It doesn't matter who we say the base or the height is, as long as we know that it is an altitude, which is typically your h, and a base, which is the segment that it forms the 90-degree angle with. So here I have 15.3x over 2 is equal to my area of 93.3. In order to do this, I would multiply both sides by 2. And I end up with 15.3x is equal to 18. So I get 186.6 is equal to 15.3. If I then divide both sides by 15.3, I get x is equal to 12.19, which means that x, if I'm rounding to the nearest tenth, which would be this place, would be 12.2. So x equals 12.2. Okay? On this guy, notice I didn't have the altitude this time, and the side that makes the 90 degree is 3.6. So once again, we have area equals base times height over 2, which means that I have 3.6x over 2 is equal to 5. We once again multiply both sides by 2, so that we get 3.6x is equal to 10. We then divide both sides by 3.6. I get x is equal to 2.77. Again, I'm rounding to the nearest tenth, so x is equal to 2.8. And that's just a little recap on how to find a missing side if given area, or how to find area of a triangle. Now, we use altitudes in order to calculate the centers of a triangle. And in this case, we're trying to calculate the orthocenter, and the orthocenter is where the three altitudes concurrent or intersect. Okay, so wherever the three altitudes intersect is our orthocenter. And it can be interior, exterior, or on the side of a triangle. And if we see with the acute triangle, which we said all altitudes would be inside, our orthocenter intersection is inside the triangle. Whereas with the right triangle, the intersection is actually at the vertex of the 90 degree is where our orthocenter is. So a right triangle is going to be at the vertex of the 90 degree, whereas for the acute, it's inside the triangle. And over here for the obtuse, we see that we have to extend all of our altitudes past the vertex so that we can get our 90 degrees. So there's our 90 degrees here. There's an altitude. There's the other altitude. And here's our other altitude. But in order for them to intersect, we have to continue our lines, our altitudes, until we hit our orthocenter. And this one is outside the triangle. So if I have an acute triangle, the orthocenter is inside. If I have a right triangle, the orthocenter is at the vertex of the 90 degree or on the side of the triangle. And if I have an obtuse triangle, then the orthocenter will be outside. Remember, the key thing for orthocenter is that it's the altitudes that intersect. And altitudes are segments that form a 90-degree angle from a vertex to the opposite side. Okay? Altitudes. 90-degree angle. Okay? So, that is it for altitudes and the orthocenter.